Okay, hello everyone. Today I'm going to be solving another Leetcode daily challenge. The problem is profitable schemes. So we are given a group of n members. In the list of various crimes they could commit, the I crime generates a profit of profit I and requires group of I members to participate in it. If a member participates in one crime, then member can't participate in another crime. Let's call a profitable scheme any subset of these crimes that generates at least minimum profit, and the total number of members participating in the subset of crimes is at most n. Return the number of schemes that can be chosen, since the answer may be the very large. Return it in modulo 1 in 9 plus 7. Okay, so by the problem, uh, let me try to explain it to you. So what the problem states is, we are given n minimum profit group and profit array. So now what we could do is, okay, so now let's see, if we are given the profit as 2 comma 3 and the group members are 2 comma 2. So what the problem states is, take we can keep on taking group members until we either reach a profit of uh, 3 or until we have the group members exceed by 5. Okay, so since the sum of 2 and 2 is 4, so that is very clear that we can take all of them, and it will never go beyond 4. Now let's look at another test case. In this case, n is equal to 10, minimum profit is 5, and groups is 2, 3, 5, and profits are 6, 7, 8. So let's see if what I can do with this. If I take this index, then number of then what would be the number of groups that I have chosen? That would be 2. The profit that I have occurred is 6, which is greater than 5. Thus, this is an option. Now let's look at another. Now if we come to this index, if we choose 3, then we have profit of 7, and we can also take this, and similarly for 5 we have 8, and we can also choose this because this is greater than 5. So this would be one case. Either we can take 2, 3 and 2, 3, 5, and then just 2 and 5, and maybe just 3 and 5. So this is pretty clear that in each index we can either take and add up the profit and group value to the state, or we can not take and just simply move ahead. Okay, so this would come out to be a dynamic programming based solution, and by take and not take, it must be pretty clear that this is sort of a 0-1 knapsack. Yes, so 0-1 knapsack is a pretty famous problem, and you must have seen it if you have studied DT. If you haven't, then let me code this a solution, and maybe you will be able to get this. So first of all, I'm going to change some variables. Let's put this as k, and I will create my helper function, which would accept an index and the value of n, the value of k, and also I need these two arrays. Also, I need the number of groups that I have taken, so let's call them groups, and also the value of sum. Okay, so the base case is pretty clear. If index is equals to group dot size, now we'll see if the thing is the number of the n must be greater than the number of groups that we have taken so far. and also the sum should be equal to k, and uh, I will show you later why I am not taking sum greater than k, because I will always make sure that sum greater than k will never get achieved. Okay, so now sum is equal to k and n is greater than equal to group. Then we return 1, else I would return 0. Also, if number of n becomes less than group in any condition, we return 0. Now this is just int not take would be just I just want to move ahead. Index plus 1 n k group and profit. Now since I'm not taking anything, groups would remain the same and sum would also remain the same. But if I'm taking, okay, so take function would be something like index plus 1 and then n comma k comma group and profit, and then finally now I have to add the number of groups, so that would be group plus group of index and sum plus profit of index. Okay, also I'm putting another condition in check, like we want to take the minimum of this and k. Now this condition would ensure that our profit would never cross k. Okay, and in the end just return take plus no take, and let's call this function. This will be 0 comma 0 0 comma n comma k, and this will be group and profit and 0 and 0. Okay, I think this should work. Let's see what. Okay, yeah, by mistake I had named it as f instead of calling it helper. So let's see now. Okay, so this is running, but as you can see, in each operation I can either take or not take. So this would go up to 2 to the power 100. In the worst case, this would be the time complexity, and since this is the solution, we can obviously memoize it. So as you can see, in each step there are 3 things that are changing. That is the index, and the second is group number of groups, and the third, that is finally sum. Okay, so obviously I can create a 3D DC and maintain each of the indexes, each of these values, and store it in a DC. So let's memorize DC int DC, and okay, and let's fill the values of DC as -1. So now all values are -1. Now we'll see if DC of index comma group comma sum is not equal to -1, then I would just want to return this, and also pass in here DC of index comma group and sum is equal to take and plus not take. Okay, let's try to submit this. Okay, so for some reason this is giving a TLE. Okay, yeah, I forgotten this very important condition. I have to do the modulo with 1 9 plus 7. So let's define mod as 1 9 plus 7. This is just another way of writing 10 to the power 9 plus 7. You can obviously write it the way you want. I prefer writing it this way. And mod, and also just for a check, let's put another mod on this side. Now let's run this. Yeah, accept it. Okay, so I wouldn't put this problem in hard category. This is a pretty easy problem if you just know 0 1 abstract properly, because all you had to do was take or not take. And I think the base conditions are also very similar. Yeah, I think this is a upper medium level problem, but nice for revising the concepts. Okay.